Now let's look at finding the average value of a function over a plane region. I'm basically extending the ideas we worked with for functions of one variable to working with functions of two variables. When I had functions in one variable that were integrable over a closed interval from a to b, we found that the average value was given by the average of the function is equal to 1 over b minus a times the integral from a to b of f of x dx. And you'll notice that this is just an integral over the length of the interval from a to b divided by the linear distance of the interval from a to b. In order to extend this to a function of two variables, I take an integral over a region R and then divide by the size of the region, which is the area in a 2D case, so that the average value of an integrable function f over a region R is given by the average value of the function is equal to 1 over the area of the region times the double integral over the region of f of xy dA. So let's work an example. I want to compute the average value of the function f of xy is equal to 4 minus x minus y over the region that is given by r is equal to the set of all xy points such that 0 is less than or equal to x, which is less than or equal to 2, and 0 is less than or equal to y, which is less than or equal to 2. The region is a square that has dimensions 2 by 2. This gives me an area of 4 square units, so that the average value of my function, 1 over the area of r times the double integral over the region r of f of xy dA, becomes 1/4 times the double integral over the region r of 4 minus x minus y times dx dy. The inside integral is the integral from 0 to 2 of 4 minus x minus y dx. This gives me 4x minus x squared over 2 minus yx evaluated from 0 to 2. I get 8 minus 2 minus 2y, which reduces to 6 minus 2y. This becomes my integrand in my outer integral, and I take 1/4 of the integral from 0 to 2 of 6 minus 2y dy. It gives me 1/4 times the quantity 6y minus y squared, all evaluated from 0 to 2. I plug in the limits of integration, and I find out that my average value for my function is 2. So now you get to try it. Pause the video and find the average value of f of xy is equal to sine x times sine y on a region defined by r is equal to all points xy, such that 0 is less than or equal to x, which is less than or equal to pi, and 0 is less than or equal to y, which is less than or equal to pi. When you're ready, restart the video to check your understanding. So I'm looking for the average value of the function f of xy is equal to sine of x times sine of y on a region defined by the set of all points xy, such that 0 is less than or equal to x, which is less than or equal to pi, and 0 is less than or equal to y, which is less than or equal to pi. The region is a square with dimensions of pi by pi, which has an area of pi squared units, so that my average value will be given by 1 over pi squared times the double integral over the region r of sine x sine y dx dy. The innermost integral is the integral from 0 to pi of sine x sine y dx. This gives me negative cosine x sine y evaluated from 0 to pi. This simplifies to 2 times the sine of y. I plug this as my integrand into the outer integral, and I want to find 1 over pi squared times the integral from 0 to pi of 2 sine y dy. This gives me negative 2 cosine y evaluated from 0 to pi, and I get 4 over pi squared. I leave it in this form. This is the exact value. This is how I can extend my idea of the average function value to functions that are defined in two independent variables. Be sure and let me know if you have any questions.